This is Lab 2 by Maddy and Meredith. The main problem was we worked to use a Plato resistor in a circuit to run an LED light bulb and electric motor at the same time in parallel. For the main punchline, the circuit was found to power the fan and the light bulb and contain a Plato resistor that was found to have an R value of 30.1 ohms. The motivation was to use a homemade resistor in a circuit to accomplish a function. Our research question was, can a homemade Plato resistor be used to complete a circuit with a functioning LED bulb and electric motor? The goal of the experiment was to use a homemade Plato resistor in a functioning circuit. Here is our experimental design. Plato was made into a sphere shape to function as a resistor. We were given a small LED light bulb and electric motor. Alligator clip wires were provided along with manufacturer's resistors. The materials were assembled into a functioning circuit with both the LED bulb and electric motor fan functioning. We apologize for the quality of the photos of our circuit shown, as we realized the amount of cords made it very difficult to understand visually. However, to better show how our circuit was constructed, the next slide shows a circuit diagram. These photos give evidence to support that the circuit we built functioned so that the blue fan and light bulb were both able to light up at the same time with the homemade Plato resistor and known 1200 ohm resistor connected through wires to one power source. We were able to accomplish this by putting the known resistor and Plato resistor in series with one another and putting them in parallel with the light bulb and the fan. This diagram more clearly depicts the circuit we created, showing the light bulb, fan, and 1200 ohm known resistor / Plato resistor in parallel with one another, and with the known resistor and Plato resistor in series with one another. We used a 6-volt power source for this circuit composed of 4 batteries. We found the resistance of the motor to be approximately 1 ohm. We found this by dividing the voltage of the power source 6 volts by an approximate current of 6A. We found a primary source that told us that the specific type of motor we use in our circuit, it would have a current between 0.35 to 4A. After talking with the instructional team, they stated that this source was a reliable reference and that other groups had found the fan/motor to have a resistance of about 1 ohm and to use this for our value. Another aspect we calculated was the internal resistance of our circuit for the batteries we used. We calculated this to the right, where we knew that each 1.5 volt C battery had an internal resistance of 0.15 ohm. This was completed in order to determine the R value of the LED light bulb. We gathered the graph above from a source listed on the slide. The slope was taken of the steep part of the yellow line since the LED light we used was yellow. This value gives a value representing I over V. Then the inverse of this value, also known as the inverse slope, was taken to determine the R value of the LED light. This value now represents V over I, which is the resistance of the yellow LED that we use in our circuit. The x-intercept of the yellow line represents the voltage of the backwards battery immediately following the LED light in our FET simulation, and is approximately 1.25 V. For our lab, we made a sphere homemade resistor out of pink Play-Doh with a radius of 2.54 centimeters. Its area was 81 centimeters squared. We played around with measurements to find a cylinder length that made the same area and radius so that we could use this length for further calculations. This work was completed in the pre-lab. Here, we measure the resistance values of many pink Play-Doh resistors while changing the length and keeping all other values constant. We calculated row values for each of the different length resistors and averaged these values to establish a row value to use in further calculations. Here, we used the row equation above and plugged in the values calculated in the previous page to determine the resistance of our Plato resistor to be about 30.1 ohms. Due to the fact that we ran out of time to collect data in class, we plugged in all the information determined on the previous slide into the FET simulation and collected V and I values. We then calculated R values with doing V divided by I and P values with doing V times I. The data is shown above. From the power values on the previous page, we constructed a power box for our circuit that can be seen above. There are 4 main physics ideas expressed in this lab report. Resistance is defined as the flow of charge disruptions. There are 2 equations for resistance. R equals V divided by I, and R equals rho times L divided by A. Current is defined as the flow of charge and can be expressed as I equals V divided by R. Voltage is defined as the electrical potential and can be expressed as V equals IR. Finally, power is the rate at which energy is transferred to do work and can be expressed as P equals VI. There were many limitations and struggles in this lab. First, we were only able to make the resistor just before the battery 0.5 ohms instead of 0.6 ohms, the light bulb resistance 16.5 ohms instead of 16.66 ohms, and the backwards battery right after the light bulb 1.5 V instead of 1.25 V because FET only allows you to go in increments of 0.5. This could have changed some of our data. Our Play-Doh was a cube instead of a cylinder that we measured in the pre-lab. However, we accounted for this as previously explained. We also did not take the necessary measurements with the voltmeter in class, so we were forced to try and create the circuit using FET and outside resources to figure out necessary values of resistance for the light bulb, motor, and fan, and many other things. Also, resistance values, voltage drop, and current values for the voltmeter in the pre-lab assignment were very different from one another, causing the calculated row value to be different from one another, causing it to be incorrect. We averaged the values together to find one row value for the Play-Doh. However, we recognize that this value may be slightly off.